This class we will introduce OSPF, advanced features. Actually, before we have learned the OSPF part, and the OSPF basic principles includes many OSPF basic characteristics. But sometimes in the industry environment, we have to meet the scenarios like the irregular area deployment, right? And like the security authentication. So to meet these requirements from our customer, so we have to learn more advanced features about OSPF and to deploy these advanced features in our industry's environment. Okay, so for the OSPF advanced features, we include these parts. First is the virtual link, and second is default route, and third is route summarization. And next is security authentication. So the last is passive interface. Okay. So the first page is introduce many advanced features in our OSPF protocol. The OSPF routing protocol provides rich features to ensure high reliability, security, and scalability. So actually, for the virtual link features actually is to deployed for the irregular area. Sometimes maybe in our industry we can't deploy the area like the backbone area connect to our non-backbone area indirectly. Maybe we will split the backbone area with 2 or more paths. So now we have to use the virtual link to solve this problem. And maybe sometimes we need to default the route information to other routers belongs to other area. Okay. Maybe sometimes we have to deploy the authentication. So here the OSPF supports the authentication. In OSPF, we support the interface authentication. We also support the area authentication. So for the two authentication, actually to prevent the unauthorized devices from obtaining network routing information. So for the authentication, we have different tabs, like the clear text, like the ciphertext. So for the two different authentication tabs we will use in our environment. Okay, so the last is OSPF supports route summarization. Actually, the route summarization is help us to manage our network easily. And the route summarization can reduce the number of routing entries and lower the requirements on device performance because every router don't need to store many routing entries in their routing table. So this action can help the device work better. Okay, next, let's end into the first part. It's a virtual link. Actually, the virtual link, we can see some application scenarios here. For the first topology, and we can see here is the 3 area. First is area 0, and second is area 1, and third is the area 2. And for the 3 area, we know when we deploy the OSPF area, we have to follow some rules. The follow rules like the first is the backbone area have to connect with non-backbone area directly. And the second rules, we have to set area 0 is the backbone area in one OSPF process. So now we can see for this topology, actually the area 1 connect with the area 0 directly. But for the area 2, is not connect with the area 0 directly, right? So actually, this topology is against to the rules of the OSPF area. So maybe the topology will cause some problems in our environment. And here we can see some problem as follows. The first is area 2 is not directly connected to the backbone area. So for the backbone area is area 0, and for the area 1 is connected with the area 0 directly, but the 2 is not. And in the topology, we can see the ABR device, right? The R2 is the ABR device connected with R1 and the R3. So here we can see the R2 is the ABR device, belongs to the area 0 and belongs to the area 1. Okay. And another device, actually, the R4 is connected with area 1 and area 2. But for R4 device, do you think is this a ABR device? But here we can see that R4 is not a real ABR because we said the ABR device is connected with 2 areas, and for the one of the area is a backbone area, and another area is non-backbone area. So for R4 device, we can see the R4 device connect with area 1 and the area 2. The area 1 and area 2 is 2 non-backbone area. So the R4 is not a real ABR device. Because the R4 is not a real ABR device, so the R4 can't transmit the routes information between 2 areas. And then we can find if the R4 can't transfer the routes from the R1 to R2, so the area 2 can't communicate with the area 0 and can't communicate with the area 1. Okay, now the routers in area 2 can only learn the routes in the local area, and routes in the area 0 and area 1 cannot discover routes in area 2. So how to understand it? Because when the routes transmit from the area 0 to area 1, and the R4 can't transfer the route information to area 2. So for the area 2, it cannot learn the routes from the area 0 from the area 1. And for the area 2 device, an area 2 device want to transfer the routes from the area 2 to area 1, but actually we know the non-backbone area device can't communicate with the non-backbone area device directly. For the non-backbone area device want to communicate with each other, they have to transfer the info or transfer the routes to the backbone area, and then the backbone area can help you to transfer the routes or information to others non-backbone area. So here the R5 will transfer the information to R4, but for area 1, actually we can't receive the information from the area 2. So the area 0 exactly can't receive the routes from the area 2. This is the problem for the non-backbone area cannot communicate with the backbone area. Okay, so for the next topology, we also can see this topology is a not regular topology because for the OSPF area rules, we also have another rule. It means for just one OSPF process, we have only one backbone area. So here we can see we have 2 backbone area, right? We have 2 area 0. So for this topology, actually, it's also breached the rules of OSPF regular area deployment. And for this topology, we will meet some problems like the first, area 0 is violated by area 1. So here we can see the area 0 is connected with area 1, and then the area 1 connected with another area 0. Okay, and the second is to prevent the loops, so R4 does not transmit the roots in the left area received from the R3 to R5. So here we can see for the roots information, and here we can see the R1 transfer the roots information from the R1 to R2. And then the R2 will transfer the information to R3. And then the R3 will transfer the information to R4. Okay, after this, we can say for the R4 interface, want to transfer the roots information to R5, but actually the R4 cannot transfer the roots because to prevent the loops. So what does it mean? It means for these roots, actually the R1 sent to R2, and then the R2 sent to the R3, and the R3 sent to R4. When the R4 device wants to send to the R5, and the R4 finds for this route actually is from the area 0 and then to the area 1. If I want to send this router information to R5, but the R5 belongs to the area 0. So the R4 device, to prevent the loops, it won't transfer the roots to R5. So the R4 cannot help the R5 get the root information from the area 0 from the area 1. Okay. And for the same is to prevent the loops. The R5 will send the information to R4, and then the R4 will send the information to R3, and R3 will send the information to R2. But actually, for the R2 find, this route is from the area 0 and then to area 1. But next hop belongs to the area 0. So it means this route has already existed, maybe in the area 0 or the R1 device. So the R2, to prevent the loops, the R2 won't transfer this root information to the R1. It won't transfer the roots from the area 0 to another area 0. So the two problem will cause the R1 can't communicate with the R5. For other device connected with the R1 and the device connected with the R5, and they can't communicate with each other. So actually, the irregular area scenarios may cause the communication problems in the network. So to prevent this problem, we have to create the new feature. It's the virtual link. Okay, and for the virtual link, we can say the virtual link is an extension of area 0. So how to understand this sentence? It means actually the virtual link can create the turnout between different routers. So here we can say for this topology, the R2 and R4, we set the virtual link between each other. So it means for the R2 and R3, we create the turnout between them. And if the root wants to transfer to another device, so the root can send through the virtual link directly. Okay. And here is the same for this topology, and for the virtual link can create the turnout between R2 and R4. So the R2 wants to communicate with another router, and R2 can send the root information to the R4 directly through the virtual link. So this is the extension of area 0. Okay. And then after we configure the virtual link, the R4, R5 can connect with area 0 directly because the virtual link is an extension for area 0. And second, virtual link is deployed to solve the problem that an area is not directly connected to area 0 or area 0 is valid. So here we can see for the R2 and R4 we create the virtual link, and for the area 2 before we haven't configured virtual link on R2 and R4, and the area 2 is actually not directly connected with area 0, and the R4, R5 for these two routers can communicate with the area 0. So now, if we configure the virtual link on R4, it means it creates the tunnels for the area 2 device. It means we build the directly connection with area 0. Okay, so this is the first topology. Actually, in this topology, the virtual link is solve the problem that an area is not directly connected to area 0. So another topology here we can see, in this topology we have two backbone area, right? We have two backbone area, and the area 0 is valid. And it will cause the R1 device can't communicate with the R5 device directly, and they can't transmit the route information between each other. So to solve this problem, actually we configure the virtual link on R2 device and R4 device. Then the R5 device and R4 device want to transfer the routes to another area 0, and we can transfer the route information through the virtual link straightly. And then it seems the area 0 can connect with each other. Okay, so this is the virtual link. And after we learn the virtual link's function, we have to learn how to configure the virtual link. So here is a configuration example. And here, to remember, we have to configure the virtual link commands on ABR device. So we know the ABR device is the device which connect with two area. So here we find for this topology, the R2 device is a ABR device. And for the R4, actually is not a real ABR device, but now we have to configure the virtual link. The R4 is connected with two different areas. So the R4, we also have to configure the virtual link. And for this topology, configure the virtual link. The command is very simple. It's the area at the area ID at the virtual link at the remote router ID information. So here we can see for this topology, the R2 device, the root ID is 2.2.2.2, and the R4 device root ID is 4.4.4.4. And with the R2 device and the R4 device, we can see we create the virtual link between each other. So we have to configure the commands on R2 device. So here is the R2 device, and this is the R4 device. And for the R2 device, first we have adding to the OSPF process. So this is the router OSPF 1, we adding to the OSPF process. And then we configure the area for the area 1, because actually the virtual link goes through with the area 1, right? So if the area ID will change to 3 or 4 or 5, we have to change the virtual link to become the 3, 4 or 5. So for the area ID, this parameter is a virtual link goes through the area. The area ID will set to become the virtual link area ID information. So here is area 1, and then virtual link. This parameter is a remote root ID. So here we can say to R2 device, the R4 is the remote device. And for R4 device, the root ID information is a 4.4.4. Okay, and move to R4 configuration. For the root OSPF1, of course, we have to enter into the same OSPF process and then set the area ID information, set the remote root ID information. So for R4, the remote router is R2. And for the R2 device, the root ID is 2.2.2.2. Okay. So here, please remember, if the root ID information we configured as the physical interface, so we have to set the remote root ID to become the physical interface. So sometimes we suggest you can create the loopback interface as the root ID information, and then for the virtual link, you can use the loopback interface to become the root ID information. Okay. And for the virtual link, we have finished the configuration and we can use some commands to check the status of the virtual link. So here we can use two commands. First is the show IP OSPF neighbors. So we know this command actually is to check the neighborship relationship between the two devices. So here we use the show IP OSPF neighbors, and we know the state is 4 is normal. And then we can say for the R2 device, the neighbor ID is 4.4.4, and the interface is virtual link. It means we have built the virtual link neighbor relationship successfully. And next is a show IP OSPF virtual link. So here we can see more details about the virtual link information. And on R2 device, we can see the virtual link is a 4 is up. It means the virtual link can work normal. And then the transmit area is the area 1. And the physical interface information and local address. For the R2 local address is this interface IP address, right? Is a 192.168.23.2. Okay, and another remote device actually is the interface for this R4, and the IP address is 192.168.34.4. Okay, so this is the remote address. For this two information is the physical interface IP address information. And for the virtual link, the network tab we can see is a point-to-point. And before we have introduced the OSPF network tab, such as the broadcast, such as the P2P and P2MP. Okay, and here we can see the virtual link is the P2P network tab. After this, we can see the timer interviews. First is the hello interview, and the dead interview, wait interview, retransmit interview. Okay, this interview information we can see or check here. And then we can see the adjacency state is 4, and another information we can use show IP OSPF virtual links to see more details. So for R4, we also can use this two command to check the virtual link on R4 device. So if you find the neighbor relationship is not 4, and you can check the configuration on R2 and R4 device and to make sure your configuration is correct. Okay, so this is a configuration example for virtual link. So before we also can see the another topology here, right? And for this topology, actually, we have to configure the virtual link on R4 device and the R2 device. There's 2 ABR device, so it's the same, right? Okay, so this is the part for virtual links.